Well, it turns out that partial fractions, while it is easy enough you could teach it in Algebra 2 class, does have a few little steps as you go along. So you have to kind of pay attention to these little facts. We've done some with linear factors. There's two more that I want to do. What if your factors aren't linear? And what if you have repeated factors? This is the latter. Repeated factors. Something like that. So, going through those steps again. Let's take a look at this. Step one, I want to factor my original fraction. If it factors out well, I'm in good shape. Oh my goodness, look. There's two factors that are exactly the same. Step two was to write this out. And you're going to put as many factors over there as you have, or as many fractions over here as you have factors. But here's the trick with repeated factors. Because it's the exact same thing, what we're going to do, this is x minus 3 squared, we're going to take 1 to the second power and 1 to the first. As a matter of fact, notice I have the same factor down here. If I was writing this one out, there's 3 factors, right? They're all the same, but there are 3 factors. Well, with repeated factors, if this is to the third power, I'm going to have one fraction that's to the first, 1 to the second, and 1 to the third. That's what we do. So that's the slight twist whenever you have a repeated factor in the denominator. Let's finish this up. Next step is to write out something. These are both linear here, so I'm going to write A and B. And down here, since I have 3 of them, I'll use A, B, and C. It's time we kind of concentrate on one of these at a time. Let's do example 1 up here. I'm going to take this statement here, and I'm going to multiply through by that common denominator. It turns out the common denominator is x minus 3 squared. When I am rewriting that statement out, this will divide out everything from the bottom. It will divide out everything from this one. And one of the x minus 3's will divide out, but not the other. So now I've got a statement here. I'm going to have to be really choosy about what I pick to let x be equal to. I can start off by saying, let x equal, I don't know, 3. That should make this pretty easy to solve. I get 2 equals a. Yay. Now, maybe it's a good time to go ahead and plug 2 in here and know that 2 equals 2 plus b times x minus 3. Wow. Huh. I can solve this one, but it sure does look like 0 is going to equal b. That's a possibility. That happens sometimes. And that is quite all right. So what will our final fraction here look like? A is equal to 2. And b is equal to 0, so I don't need to write that down. That's a funny little one, but we could integrate this, couldn't we? Just using normal u substitution. Now, number 2 is going to look a little bit different. Number 1 surprised me. I've never done that problem before. I thought maybe it would have a value for b, but sometimes a, b, c, d, they might have a value of 0. Don't be surprised. Okay, here's the second example. Multiply through by that common denominator. Should look like that. Now next, let's pick out some x values that might help. And it starts off really easy. If I let x equal 3, I get 2 times 3 squared plus 1 equals a plus 0 plus 0. I guess that means I know what a is. But now it gets harder. What else do I pick out for x? Nothing's going to eliminate very well, so we're going to end up just picking out 2 numbers that seem small or nice. Now I picked out the numbers 0 and 1 because they seem pretty small. When I let x equal 0, I get this formula. When I let x equal 1, I get that formula. I have 2 formulas with 2 unknowns. With 2 equations and 2 unknowns, I did substitution here to solve.